You'll never get me! You're broke, farm boy! There are too many of us.
I think we've all had the urge to demolish something really annoying. And a major leap in ag tech just made it possible. Carbon Robotics has unveiled what it calls the world's first large plant model, or LPM. The LPM is an AI system trained on 150 million labeled plants to help revolutionize crop management. The model powers the company's laser weeder robots, laser blasting weeds like the Terminator of the crop field. Not only can it terminate the weeds, but the LPM enables the laser weeder to identify and precisely kill weeds in nearly any crop or field within minutes. And another cool advantage of the large plant model is that it keeps learning. Data from Carbon's global fleet of machines continuously feeds back into the system, improving performance across every robot in real time. This will be a huge help to farmers as the technology lowers labor costs, reduces herbicide use, and produces better yields. Carbon Robotics also introduced Plant Profiles, a fast tablet-based customization tool that lets farmers adapt the AI to new crops or field conditions in minutes rather than months. Carbon Robotics shows how their design helps feed the world. And when engineers need reliable parts to achieve this, they turn to Mouser Electronics. Littelfuse L60QS high-speed semiconductor fuses provide fast, reliable short-circuit protection to safeguard power semiconductor devices and extend system life. These fast-acting fuses limit damaging heat energy during fault conditions while delivering balanced performance. Featuring a compact cylindrical design, the PowerSeed series meets UL and IEC standards for global use and simplified inventory. With high interrupting ratings up to 200 kiloamperes AC and 100 kiloamperes DC, they protect against severe fault currents. Excellent cycling capability supports frequent on-off switching, which improves overall product reliability and extends service life. The Littelfuse L60QS high-speed semiconductor fuses are ideal for AC to DC power converters, control circuits, EV charging stations, and more. Check them out today by visiting Mouser.com or by clicking the link below. What if an ordinary circuit board could secretly talk to the world? David reveals a few boards with hidden twists.
Thanks, Andy. There's a couple of really common protocols or types of communication. We use them all the time in everyday life, but you don't see them very often in industry, and there's a few reasons for it. But there are a few key places that it does show up, and these two communication protocols are called Bluetooth and RFID, or radio frequency identification. Bluetooth is a short-range communication, but it's not very secure. We don't find that controlling an automation system, but what we do find very often is a phone app that can communicate with things through Bluetooth to be able to diagnose issues, look up alarms, or be able to download new parameters. For example, a variable frequency drive or a condition monitoring sensor that we just want to be able to monitor periodically and see what's going on. The radio frequency identification is really useful in automation terms when we need to get really close to something to be able to ensure authorized access. Safety and lockout tagout are a really common place where we're now seeing radio frequency identification to be able to communicate between key members on the maintenance team to know who's accessed a secure location so that we can securely lock out all of the electronics inside. So the RFID, radio frequency identification, and Bluetooth, while they might not be that useful for control of your system and pose security risks, they can certainly be useful in allowing us to more efficiently get into, configure, and diagnose and create a more safe environment for maintaining and controlling your system. Andy, back to you.
Thank you, David. All right, it's time to adjust your knowledge gains in our SmartBit quiz with our 3 control automation questions. The questions are scored using actuator output percentage, and today we'll be testing your knowledge on actuators gone wild. Let's begin with our first question for 25%. A robot arm lifts a giant crate and starts jittering. A servo motor oscillates under high inertial load. What is the likely cause? Is it A, insufficient proportional gain, or is it B, poor phase margin due to unmodeled load inertia? And the answer is B, poor phase margin due to unmodeled load inertia. High inertia adds phase lag. If not modeled, it erodes phase margin and causes oscillation even when gains appear reasonable at low loads. Okay, let's move on to our next question worth 25%. A heavy-duty AC motor tries starting under full load but keeps tripping, jerking violently as sparks fly. Why does it repeatedly overcurrent at startup? Is it A, high static friction causing stall torque demand, or B, back EMF generated too early? And the answer is A, high static friction causing stall torque demand. Static friction requires high startup torque, spiking current before motion begins. Back EMF only develops after rotation starts. Let's go on to our final question worth 50%. A pneumatic fail-open valve suddenly slams shut as air pressure drops, spraying liquid and startling nearby machines. Why did the fail-open valve close? Is it A, spring installed incorrectly, or B, controller output polarity inverted? And the answer is A, spring installed incorrectly. Fail-safe behavior is mechanical. Incorrect spring orientation overrides control logic entirely during air loss. Well, that was a tough day for actuators, but I hope yours is going smoothly. Want to try again? Just click the link on your screen and be sure to check out our other AE videos for the latest in control automation.